I'm looking for stuff like this. I'm looking for L's. Where two members come to a joint, I'm looking for B's. Anytime I see those, and there's no loads at those joints, those are all going to be zero force members. And like we said, zero force members, you might see a zero force member and then things change, loading changes, and all of a sudden the zero force member becomes load bearing. So I have given this problem on a test. I have given this problem on a test. So two of these are old test questions, A and F. So I want to blow this up a little bit so we can, yeah. There we go. So, zero force members. There's lots of members here. The more I get away by getting the zeros and equals and opposites and so forth, the easier it is to solve a trust problem. The first thing I notice right here is straight lines going up. Usually an indication of straight lines going up, those members are going to be in compression. Why? Because they're sort of acting like commas. So before I even start, I'm thinking whatever the number is, 100 pounds, 200 pounds, 5 pounds, whatever, these are all going to be probably in compression. That's the first thing that comes to my mind. I see a column looking type thing. Columns carry loads in compression, right? So I'm thinking those are in compression members. So, zero force members. I look right away, and oh, by the way, you see in essence a line of symmetry. So, what I see here, I see over here. So really, if I can notice that, that means I don't have to work as hard because whatever I see here, I'm going to put over there. There's a very symmetric truss. The first thing I see is I see a V. You see the V? Sideways V, but it's a V. With no load. 0, 0. Then I see a T. There's the T right there. And like I said, it doesn't matter that there's 10,000 pounds over here. Every joint must be in equilibrium. That means joint E must be in equilibrium. Well, if that's 0, this is 0, that's 0. What's that? No, it's not the p-value. But it's symmetric. 0, 0, 0, 0. So I haven't done a single thing. I haven't put any equations down, and I've already got 2, 4, 6, 8 members already done. Right? Okay. What else? Well, I can see this guy right here. It looks like a T, but there's a load. That means this member has to point upward, and it has to have the same value, 10,000 in C or compression. If I look at that joint I gotta have 10 down, 10 up in order to balance everything in the Y. Correct? So that means if I'm pushing up against a joint, that has to be 10 in compression. What else do I see? Well, I see another T here. This is equal to that. That's 0. Another T here. That's 0. That's equal to that. Then I see down here, if I take this roller out, what will I see? I'll see an L. There's the L right there. With the roller, it now looks like a T. So that means this member has to be PY, whatever the value of PY is, in compression. That member has to be 0. So there's a lot of things that are happening, and I haven't written a single equation down. I haven't drawn a single free body diagram, nothing. And I've already got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 members, and I haven't written a single equation. Nothing. Absolutely nothing. Right? I know this member has to equal that member because of the T joint. And there you have it. This is what I would know so far. This one would have an AY and an AX. By looking at this, I can see AX is 0. There are no forces in the X. Do you agree? There are no forces in the X. You see that? Now these are the obvious ones. There are, however, some that are not so obvious, and there are 0, 0, 0. So the ones I put zeros in blue, those are not so obvious, but they're still zeros. Here's why those are zeros. If I look at this joint, I will have some value AY, whatever the reaction is. There is no AX. I have a 0 here, because I already found that. I'd have some force this way, which I'll call FAO, and I'll have a FAB. That's the joint free body diagram at A. This is 0. That's some force AO. That's some force AB. And then there's the reaction AY. Yes? Sum the forces in the X. Positive in this way. Well, that's in the Y. That's in the Y. All I have is FAO. Let's call this theta. Cosine theta equals 0. Well, if there's an angle, that cosine theta is not 0, so the only way this is going to be 0 is FAO is 0. So that's why FAO is 0. So you can see that those are all zeros. So I got a ton of zeros in here. Ton. Now, if you do MD solids, what?
Could you have also determined that by saying that was a V?
That was what?
That the blue zeros, those are all V's, right?
Those are all what?
V.
No, you can't say these are V's because there's a load. If there's no load, now this looks like a V. But there's a load, so it kind of changes a little bit. So this is what MD solids gives you. Oh, shoot, that's too big. This is what MD solids gives you for this trouble. As a matter of fact, it does give you the support reactions, AY, BY. It already tells me AX is 0. And then you can see, it's telling me this is 20C, compression, 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 all the way up. Why? Because it's acting like columns. So literally, it will take you longer to draw this up. And it's not that hard. You can see, you tell it, give me 1, 2, 3, 4, 5 grids vertical. Give me 1, 2, 3, 4, 5 grids horizontal. And then you just start here and just connect dots or connect lines. And that's all there is to it. And then when you say compute, this is what comes out. You with me? All right. Let's take a look at this one over here. What do I have? 0, 0, because these are L's. 0, 0. Notice 0, the same, 0, the same, 0, the same. Well, shit, I got the entire thing just about. The only thing I don't know is what are these diagonals? Other than that, I've got the trust pretty much done. Yeah? Do you see the L's? There's an L, there's an L. Do you see the T's? There's the T, there's the T, there's the T. The non-collinear member in a T with no load on it is going to be 0. Okay? Let's take a look at this one down here. Upside down V, no load, 0, 0. There's a T here, 0, 0. Take all this away and I have another upside down V, 0, 0. Must be an architect. It looks cool, but it's all 0 force members. Notice I see an L, 0, 0, no load. I see another sideways T, 0, they have to be the same. And if this is 0, right, this becomes an L with a load. So this has to be 5 in tension because it's got to pull the other way in order to balance in the X. That has to be 0. Well, shit, we pretty much did the entire truss and wrote no equations. Wrote no equations. Let's take a look over here. V's, 0, 0. There's a T. That's 0, that's 0. There's another T, 0, 0. Oh, sorry. So here's my V. Here's my T. If that's 0, that's 0, that's 0. If all of this is 0, then you can take all of this away. What I now have is a V, sideways V, 0, 0. Here's a T, 0, same. L, 0, 0. Here's a load dy, which means this member HD has to be dy in compression, and that member has to be 0 because it's an L. Now, is this going to come to you easy? No, you got to practice it. Like everything else in life, you practice it, it'll become second nature. But you got to practice it. All right? This one right here, I see a V, 0, 0. This member has to be this member has to be 2 kips in tension because it's got to pull this way. So it's pulling on that joint. That's got to be in compression. Right? That has to be 0 because it's basically a T with a load. This I know is in 2 in tension because it's got to be pulling upward in order to balance. The rest of it, I don't know. I don't see any standard regular V's and L's and T's after that. So I'm looking at this going, okay, once you get to a number that's 1, 2, 3, 4, 5, ain't none of these gonna be 0. You look over here, I got 1, 2, 3, 4, probably not zeros. What you really want to home in on is 3 members, 2 members, for the most part. Anything above 3, you're done. There are probably no zeros. Okay? This one right here, I told you, is an old test question. Notice it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 members, or 12 joints. Times 2, that's 24 equations you're going to have to write. 24 equations. How many members? Well, there's 24 minus 3 for reactions, so there are 21 members. So I got to find 21 members. Now this was an old test question which said, hey, find me the support reactions find me all the members. I mean, I find 21 members. Okay? So the first thing I would do, especially on a test, for me, is go in there and find zeros. There's a V, 0, 0. There's a T right here, HJ, right? There's a T, if that's 0, that's 0, that's 0. So this whole side here is 0. So I've got 1, 2, 3, 4. 4 members, already solved for. I didn't write a single equation. 21 members total. I'm down to what? 17? Great. Let's keep going. See if we can find something else. I see a T here with a load. That means this member's got to push upwards, same amount. So that's got to be 10 in compression. I just now have 5 members. This member must equal that member because it's a T with a load. Yes? So I look at this and I say 1, 2, 3, 4, 5. 5 members. And once I found this one, I found that one. So I really have already found 6 members, in essence, in my mind. Look at this right here. I got zeros. So all this is gone. What do you see here? I see an L with a load. Right? Take the load out, take this out, you see an L. But with the load, it becomes, in essence, a T. That's going to be 0. This value right here has to be 10 kips in tension because it's got to pull upwards in order to balance the downward T. Is everybody seeing this? So what did I just find? I found another 2. So I've already got 8 of the 21 members done, in essence. Next, I see another T here, sideways, but still a T. That's 0. That has to equal that. That's 9, 10, because once I found DC, I found CB. Here's another T, 0, down to 9. I find this, I found this, down to 8. Here, I have a AX from the roller. Well, you take this out, what do you see? An L. Well, that looks like now a T, so this has to be AX in compression, and that's got to be 0. So I'm down to 6. So I started out with 21 members, and all I really need to do is find 6 of them. That's it. Well, hell, I can do 6 in 15 minutes, probably. Probably less than that, but it doesn't take a whole lot of time to get 6 members. There's actually one member that's a zero force member that you probably can't see because I hid it from you. And the member that's hidden from you, I'm going to draw it up in black right here. Can you see the member now? That's going to be 0. Now, do I expect you to see that? No. Will I expect you to see that 2 classes from now? Yes. Again, you're babies. Nobody wants to teach you babies. So what do I do? Nora will train them. Let's put Nora on. Bring them on. Let's go. I don't mind. So yes, there's another 0, but it's probably not one that you would find easily. So if you look, this will be the second problem we do in the Pro Copy booklet. So you can see the actual process of what I'm going to go through to solve this. The first step of solving it is go through and find these zeros. You don't have to find all of them. You find the ones that are pretty obvious. I And then you can use the equations of equilibrium to get the others. Like this one right here, I doubt you will see this one. That's okay. Once I start doing the method of joints and I go to this joint, you'll see that this number is indeed 0. Okay? Questions? Okay. So, come Monday and Tuesday, I start solving truss problems using the method of joints and method of sections. Alrighty? We have not done in the help session, namely distributed loads. So this is the last part of chapter 4. This is help session now. Last part of chapter 4. And then we'll pick up into chapter 5 and go from there. Alright? So next week's quiz. Next week, not this week, next week's quiz will be exactly this. Okay? It will be exactly this. Not that same problem, but the distributed load type of problem. And you'll see a couple of them in your testing manual. So that's next week's quiz. Okay? So it says the distributed load acts on the beam is shown. Find me the maximum. Ooh, keyword maximum. When somebody says maximum to you, what's the first thing you think of? Huh? Derivative. Yeah, that's the first thing I think of. Find me the maximum intensity, Wmax. B, what is the magnitude of the equivalent resultant, and where does it act? In other words, I got a parallel coplanar system. We know any coplanar parallel system can be reduced down to a single force at a known location. Correct? And then we bring in chapter 5, find me the support reactions. Well, what are the support reactions? I got a pin over here and I got a roller over there. Great. So first part, let's get the maximum force intensity first. Right? So I got to take a derivative of my W of x. So dW dx is equal to minus 4x plus 4. Minus 4x plus 4. And I'm going to set this equal to 0. From calculus, when I set it equal to 0, what am I getting? I'm getting the critical points. These are the possible max and mins. Remember that? I gotta teach you calc too. So I get x equals 1. So at x equals 1, this is the possible max-min location. What calculus do after you get that x1? They said, oh, well, you can do the first derivative test, which is find x1, go to the left, go to the right, etc., see the concavity. Or you can do the second derivative test. I like that one better. I don't have to work so hard. So d squared w dx squared is equal to minus 4. Well, if the second derivative is less than 0, what do you have? Max or min? If it's positive, it's a min. So x1 is a max. So now I come in and I say W max, therefore, is equal to minus 2 times 1 squared plus 4 times 1 plus 16 is equal to 18 pounds per foot at x equals 1. So I just found part A. Part B, I gotta find that single force resultant, and then I gotta find its location x. So I'm gonna say single force resultant is equal to integral a to b w of x dx. This is integral 0 to 4 of minus 2x squared plus 4x plus 16 dx. So single force resultant is equal to minus 2x cubed over 3 plus 4x squared over 2 plus 16x. Evaluate from 0 to 4. If you do that, you're going to get 53.33 pounds. There's my single force resultant. Where do I locate it? How do I find the location? I say to you, moments of the original system must equal moments of the reduced system. Well, what are the moments of the reduced? In other words, what I have now is this. That's original system. I'm down to a single force resultant 53.33, and I'm going to say X. So the moment here is 53.33 X must equal to the moment here, which is integral A to B X times W of X dx. So this is integral 0 to 4 of x times minus 2x squared plus 4x plus 16 dx is equal to 53.33x. So this becomes minus 2x to the 4th over 4 plus 4x cubed over 3 plus 16x squared over 2, evaluate from 0 to 4, must equal to 53.33 times x. You solve this, x will come out as 1.6 feet from A. And the reason I say from A is because in essence, I'm saying this is point A, and I'm going around A this way, clockwise. So I'm going from A. What the hell? No. So I know exactly where to locate it. 1.6 feet from A. Now comes chapter 5. Chapter 5 says, draw me a free body diagram. Well, in this case, the free body diagram is, I'm going to cut through the pin, cut through the roller, cut through back. So this is a pin reaction, AY, AX, BY, and I know this is 53.33 at some distance x, which is 1.6 from A. Agreed? Now I'm just going to write my equations. What is AX equal to? Yeah. Some forces in the x equals 0, positive to the right, AX equals 0. What's your next move? Yeah, let's do a freaking moment. I'm going to sum moments at A equals 0. And I'm going to take counterclockwise positive. That's BY times 4 minus 53.33 times 1.6 equals 0. BY is equal to 21.33. Some forces in the y equals 0, positive upward. That's going to say AY plus BY must equal to 53.33. I'm going to dump that into there. and I will come up with AY equal to 32 pounds. Upward, upward. They're both positive, so I'm a genius. I guessed correctly. Questions? Questions on this? This will be quiz next week. It will be just a problem, just like it says in the testing manual. I think you have 2 of them in the testing manual similar to this. So that's what you're going to get next week. Okay? All right. Let's look at the next problem. Is everybody good? Next problem. Another distributed load. So it says, for the beam shown, determine the reaction supports. I'm not even asking you to reduce, but you know you're going to have to reduce it, the distributed load, to a single concentrated load. So there's lots of ways to do this. Hey, this looks like a trapezoid. Do you remember the equations for a trapezoid? If you do, great. If you don't, that's not the end of the world. So I'm going to do this way. I'm going to do area 1, which is a triangle, and area 2, which is a big old rectangle covering the entire beam. So I have single force resultant 1 is going to be 1/2 base times height. That's 1/2 times 6 times 300. Remember, this whole thing is 9. This is 6, so this is only 300. Which gives me 900 pounds. Where is it acting? Well, from the fat end, it is 1/3 of the base. From the skinny end, it's 2/3 of the base. So this will be from A, 1/3 of 6, which is 2. From A. Single force resultant 2 is base times height. Base is 12. Height is 600. That's equal to 7,200 pounds. At, what's the midway of, at 6 feet from A or B, really. Questions? So now what I have is, I just took this and turned it into this. A single force, 900, 2 feet away. And I've got 7,200, 6 feet away from A, from B. B, if I draw the free body diagram now, B is a pin. That means I have to have a BY, BX. Roller, AY. It is not uncommon for your BX to be 0. Why? Because beams are not intended to carry axial loads. So it's not uncommon for this guy to be 0. Beams carry loads perpendicular to their axis. That's the intent of a beam. So again, some forces in the x equals 0, positive this way, Bx equals 0. Some moments at A equals 0. Counterclockwise positive. That's going to say By times 12 minus 900 times 2 minus 7,200 times 6 equals 0. So this says By is equal to 3750. It is positive, so it is upwards. units pounds. Some forces in the y equals 0 positive upward. That says AY plus BY minus 900 minus 7,200 equals 0. Take this, dump it in here. AY comes out 4350 pounds of force upwards. So this is combining chapter 4, last section, distributed loads, along with chapter 5. Okay? Questions? Yeah.
Would you ever combine the two distributed loads?
What do you mean?
Like the 900 and the 72? Would you ever combine them into this point?
I could. Does everybody understand what he's asking?
Yes.
He's saying, hey, can I take this and make it equivalent to one single force at some location X? Can I?
Yes.
Absolutely. How? Well, what's the single force got to be? The sum of these two. Well, what the hell is the sum of these two? Huh? 8,100. Now, where do I locate that X? Well, I locate that X by saying 8,100 times X must equal to, I'm basically equating moments here must equal moments there. So that would be, if I'm taking some of the moments at A, that would be 8,100X and 900 times 2 plus 7,200 times 6. Solve for X, and you got the location of the single force, single location. So yeah, I could do that. I didn't, but you can. Is it ever useful? Sometimes it is. Depends on the problem. Sometimes it is. So I want you to look, when you sit there and say, well, it is a big deal. Here's why. This is an example problem from structures. That's 2 classes away from this class. So now it says, hey, determine the maximum moment in the simply supported bridge deck when you have a car traveling across it with a trailer. So now, 2 kips is the axle, 1.5 is the rear axle, and then the axle for the trailer is 1 kip. Notice what he does. What's he doing here? He's doing equivalence, what you just learned. So he's sitting there saying, hey, let's do a moment and reduce this load right here to a single load, which he's calling it 4.5K, and then he's locating the location of it. So he's got 3 loads, and he's reducing it down to one single load, 4.5. He's got to locate it. Moments of the original system must equal moments of the reduced. Something you learned in statics is being used 2 classes away. So when I tell you statics is a foundation class, believe me, I ain't lying to you. I haven't lied to you yet. If you have looked at everything I've said to you, there isn't a single lie in there. It's not like I'm hiding something from you. I told you exactly what was coming on the test. Number 3 was a carbon copy of every single problem that was in the testing ring. The only difference was I changed the diagram. And some of you fell for the changes. What were the changes? Coordinate system was changed. 2 forces acting downward 40 newtons. Well, they weren't couples, but yet I probably had at least 40% of the class say, oh, That's a couple, 7 times 40, 280 is the moment. No, it wasn't. Okay? So he said, let me some moments about B, get A what? Well, hell, that's chapter 5 in statics. That's exactly what that is. Then he cuts the beam, right? We're going to get to that. We haven't gotten there yet. But he made a cut through the beam right here. And now he's showing the shear force, the bending moment, which we are going to do when we get to chapter 7. It's coming. So everything that I've told you is going to come to fruition. This is structures. CES 3102 for you civils. We're doing nothing more than statics. There's nothing here other than I summed the forces, I took a moment, found the location to place that single force 4.5 kips. It's exactly what I just did here. Exactly. But now you're dealing with something more realistic. What's he trying to do? He's trying to do a moving load rather than what we're doing now is just a bunch of dead loads. So it's all coming at you. If you're going to be a civil or mechanical, you're going to need this class desperately. And if you don't get it now, you're going to have to pay attention and try to learn it when you get there, on top of learning material for mechanics and materials, which is hard in itself because there everything deforms, and once you get deformation, things get uglier. It's that simple. All right. So learn this shit now. Save yourself heartache down the road. All right. Next problem. We've actually drawn the free body diagram of this one. I'm doing this one so I can solve for the values. So when we did this problem, we said initially, hey, let's draw a free body of the whole thing. We ended up getting 2 unknowns at pin C, 1 unknown here, that's 3 unknowns, 2 more, that's 5 unknowns, which sucks. That's not an appropriate free body diagram. So what we did is we cut through here, here, and back. We cut through here, here, and back. So instead of 1 free body diagram, we're drawing 2. Okay, let's draw 2, damn it. Here we go. Free body diagram, ABC. That's this right here. I've got a CY, CX, some cable T that goes between DB. I cut it right there. I've got a load here, down here of 200. Then I'm going to draw a free body diagram of DEF. DEF. Here's DEF. I got FX, FY. I got a load EY. I got a cable tension T. And I've got a single force resultant, which in this case is 2,700. That's 300 times 9. 2,700 acting 4.5 feet here, 4.5 feet there. This is 3 feet away. Those are my free body diagrams. And again, they're in the Pro Copy booklet. We drew this already. I'm just repeating it. And now I'm going to use my knowledge of Chapter 5 to find support reactions. Where should I start is the question. Should I start at ABC or DEF? ABC. Why ABC? I've got 1, 2, 3 unknowns. Here I got 1, 2, 3, 4 unknowns. Yuck. Yes, best thing to do is do this. Some forces in the x equals 0, positive to the right. Cx equals 0. It's a beam. Beams don't carry loads axially. Some moments at C equals 0, clockwise positive, 5 times T minus 200 times 10 equals 0. Or T is equal to 400 pounds. Once I have the 400, I'm going to take that and dump it in here and say that's 400. It's the same table, it doesn't change values. Right? And then I say some forces in the y equals 0 positive upward. Cy plus t is equal to 200. Dump that t in here, you'll see Cy is equal to minus 200. What's minus sign tell me? Cy is really 200 pounds downward, not upward. Once I have this 400, now I can come over here and I can say, some forces in the x equals 0, positive to the right, nothing unusual, fx equals 0. If I do a some moments about f equals 0, clockwise positive, I'll get 3 times f minus 2700 times 4.5 minus 400 times 9 equals 0. EY comes out 5,250 pounds. It is indeed upward, I got a positive value. Some forces in the y equals 0, positive upward. That's EY plus FY minus 2,700 minus 400 equals 0. Take and dump this into here. FY will come out. Minus 2,150. Again, I guess wrong. FY is 2,150 pounds. Not upwards, but downwards. Questions? Questions? By the way, this idea of dismembering things into pieces, that's what's going to happen in chapter 6 when we discuss frames. All we do with frames is dismember them into pieces. So I've been really setting you up for chapter 6 since we started doing 3-body diagrams and dismembering things into pieces. Okay? All right. Let's take a look at a 3D. Since we finished 3Ds, let's do a 3D. You can see question number 2, old test question. I ain't hiding anything from you. So this one says a 200 kilogram thin plate is supported by a hinge at A. Hinge, you gotta know table 5.2. What's a hinge? How many forces in a hinge? How many moments? 2. What moment is missing along the axis of the hinge? Great. And a cable DE, assuming a homogeneous plate, which means it's nice and even, which means I can put the stuff at the CG, the actual weight, Find me the reaction of A, tension in the cable. Okay. Oh, by the way, if you want to see a bitch of a problem, this is in your problems in the help session. That is a nasty problem. And the reason it's nasty is because there's a lot of algebra. A lot of algebra, a lot of trig. Actually, you have to use one of the trig identities to solve it. It is not pretty. If you try it and you want to see the solution, let me give you the answers if you try it. And the reason it's nasty is it's saying, find me the angle theta. Once you ask for theta, once you're asked for an angle, you should be thinking, oh, this problem's going to be a bitch. Because the easy ones are when they ask you for the forces. The harder ones are when they ask you for an angle. So this angle is going to be ugly, or this solution is going to be ugly. The answer to this, if you want to try it, like it took me front and back of the page in order to solve this problem. I mean, it's not pretty. So you can see, there's the front, there's the back. The angle is 69.4. So if you want to try it, you're more than welcome to. It's probably not something I would give on a test because it's pretty nasty. Unless you piss me off, then it's fair game then. All right, free body diagram of this looks like this. I'm going to show over here at A, I'm going to show AX, an AY, an AZ. I'm also going to show a double arrow MAY, a double arrow MAZ. There is no moment along the axis of the hinge, which is along the X. Yes? I'm also going to show 200 down at the center of gravity. Do I put 200 in there? No, because 200 is a kilogram. So I got to say W is equal to 200 times 9.81. That's going to be 1962 newtons. And then over here at D, I'm going to have some sort of FDE. Load here is 500 along here. I got 200 along there that I'm showing here. So I've drawn the free body diagram. Again, it does not have to be fancy. I'm not looking for anything crazy. You don't have to be an artist. Just account for the forces. What's the next thing I got to do? You're faced with this problem as a test question. What's the next thing you got to do? Number one, you said, okay, hinge, 2 moments, 3 forces. No moment along the axis of the hinge. Perfect. Then you said, let me draw a free body diagram showing all the forces and moments on that diagram. What's the next move you make if this was a test question? Huh? Moment at A, he says. Is that the next move you make? You're shaking your head. Why? What's the next move you'd make? Huh? She says we got to do the 5-step process. How many agree with her? How many are sleeping? How many are thinking, shit, I should have ate something before I came? Why didn't you?
I did.
You're still hungry. I had something, but damn it, I'm still hungry. Okay. A, check the coordinate system. Is it Hibbler's? No, but it is right-handed. X, Y, Z. Second, do I have all forces in IJK format? Well, I don't know DE in IJK format, and that's why she said, hey, I gotta do a 5-step process. Yup. And the reason I have to do the 5-step process, I don't have alpha, beta, gamma, I don't have double projection. I do have a bunch of distances, so I gotta come in here and say, what are the coordinates of D? 0, 0, 9. What are the coordinates of E? That would be minus 4, 5, 0. So now, I'm going to come in and say RDE is equal to XE minus XDI plus YE minus YDJ plus ZE minus ZEK. RDE is minus 4I plus 5J minus 9K. Magnitude of DE is 11.045. Therefore, FDE is equal to magnitude FDE times the unit vector, minus 4I plus 5J minus 9K. Divide this by 11.045. FDE is therefore minus 0.362 FDEI plus 0.453 FDEJ minus 0.815 FDEK. There's my FDE in terms of IJK. So yes, I need all forces in IJK. AX, we know, AXI. AYJ, AZK, we know those. Those are easy. 800, 500, those are easy. That's going to be 500I, that's going to be the 200 in the negative K direction. So those are the easy ones, but I definitely needed this guy in IJK format. Now what? Now we want to do instantly a moment. If I don't, and I do some force X, some force Y, some force Z, I will have more unknowns than equations. That's the truth. Okay? So I want to do a moment. Well, you know what? Let's do it the stupid way. Some force in the X, positive this way. This is AX plus the 500 minus the 0.362 FDE equals 0. Or AX minus 0.362 FDE is equal to minus 500. Guess what? There's my X equation, and of course, I have two unknowns and only one equation we can't solve. That's going to happen every time you start with forces. Some forces in the Y equals 0, positive upward, AY plus 0.453 FDE minus 1962 equals 0, or AY plus 0.453 FDE is equal to 1962. There's equation 2. Some forces in the Z equals 0. Positive coming out of the paper. AZ minus the 0.815 FDE, right? Minus the 200 equals 0, or just equal to 200. Same thing. And of course, we knew this was going to happen. You write forces, you're going to get a bunch of equations, and you'll have more unknowns than equations. What do I have? I have 4 unknowns here. AX, AY, AZ, FDE. 4 unknowns. I can solve them for equations. That's why you need that stupid moment equation. So let's do a moment. Where do you want me to do a moment at? Yes. We're going to sum moments at A equals 0. That's going to be MAYJ plus MAZK plus a negative 3I plus 5K crossed with a minus 1962J. So to get from A to here, I'm going to go 5 this way and 3 that way. Well, 3 that way is in the X, negative. This is 5 in the K. That's why I have minus 3I plus 5K crossed with the 1962. Plus, I'm going to have 10K crossed with 500I plus a negative 6I crossed with 9K, I'm sorry, plus 9K crossed with FED vector. All that equals 0. Now you gotta do the math. The math is gonna lead you to MAYJ plus MAZK plus 5886K plus 9810I plus 5000J minus 4.077 FDEI minus 8.148 FDEJ minus 2.718 FDEK, all that equals 0. So do the math, do all that cross product. So this is the line that you're going to get from the cross product itself. Now, you break it up. MX, put all the i's together, set it equal to 0. MY, put all the j terms together, set it equal to 0. MZ, put all the k terms together, set it equal to 0. So here come the i's. I've got 9810 minus 4.077 FDE equals 0. Well, lo and behold, FDE comes out. 2406.18 newtons. J's. MAY, that's a J, plus the 5,000, that was a J, minus 8.148 FDE, that was a J, that's got to equal to 0. Dump this into here, MAY comes out 14605.6 Newton meter. K's, MAZ minus 2.718 FDE plus 5886 equals 0. Take this, dump it into here, MAZ comes out 654 Newton meters. Now that you have FDE, you can plug FDE back in here, here, and here to get AX 371.04, AY 872, AZ 2161.04 newtons. So you can see the easiest thing to do is instantly do a moment equation. Once you do a moment equation, values will come out, and when you write the sum force x, you'll have the values to dump in to get your ax, ay, and az. Yeah.
Like I would say, excuse me, to start with portions, but I mean, like at the same time, you're still gonna need those.
Absolutely. I'm not saying you're not gonna need them.
You
But
gotta go on first.
the way I see it is you always, as a student, want to get an answer right because it makes you feel good. The only way you're going to get an answer is if you do a moment equation first. Then you'll feel good. Right? I got an answer. Doesn't matter if the answer is right or wrong, you feel good. I got the goddamn answer. Could be totally wrong. I don't care. I got an answer. Right? Questions? Now, there is another problem. Right here. Notice what I did there is I put a double projection in there. It's hard to see the angles, but the angles are 60 and 60. 60 and 60. There's a fixed support. How many unknowns at the fixed support? 3 forces and 3 moments. Fixed support. Table 5.2, number 10. Right? If you want, I'll give you the answer to this one so you can try it yourself. MAX 12.4 that way. MAY 200 that way. MAZ 600 that way. AX 150, AY 173.2, and AZ is 86.6 headed in the negative Z direction. And the angles in that double is 60 and 60. And you can see it was a question number 2, so it was an old test question. So if you want to try it as one of your 5 problems per day, that would be awesome because it would give you something that was from an old test question. Yeah. What? Yeah, the extra points for the test, you should see it under statics. Under files, statics, test 1, redo problems or something. It should be question 1 and question 2 of the test. When's it due? Monday and Tuesday. Monday for the Monday, Wednesday, Tuesday for the Tuesday, Thursday. Got it? Nice and neat. You're going to get 22 points added to whatever you got. So if you got a 50, you're going to have a 72.2 or 72. Right? If you got a 40, you're already in the 60s. So it behooves you to do those problems so you can earn those points. Again, I want it nice and neat. Don't give me slop. Slop is going to take away points from your 11 points per problem. Okay? And you're going to get a Chapter 5 mastering homework here shortly next week. Any questions?
Are we allowed to print out the PDF and do the questions like on the printed paper, or is there a certain?
I don't care.
Do we have any extra homework or any other chapters should we learn during
Go.
spring?
You have to
Speak up.
project.
Do you have any other extra homework coming up during spring break or no?
I don't know. I haven't thought that far ahead.
Oh. We're making sure.
Maybe. He's asking me, will I have homework assigned during spring break? Maybe. Why not? Listen, spring break is for you to catch up. Because I know you're behind. And when we get back, you're gonna get smacked with a test number 2. So, it is not something for you to chill. Maybe take a few days and chill, you know, but towards the end of that week, you need to be doing some problems. So, Friday to, let's say, Wednesday, Thursday, chill. Friday, Saturday, Sunday, get back to work. Okay? Any other questions?